leveraging developments in monitoring technology for optimizing bridge maintenance. And I'd like to request Chief Engineer Construction 2, Shri Ajay Kumar, to kindly accompany the Chairman of the second technical session, Shri Ajit Pandit, Additional Member Works Railway Board, and Co-Chairman of the session, Shri Piyush Agarwal, Principal Executive Director, Bridges, Railway Board, to the dais. And I'd like to request all the presenters for the technical session number 2 to kindly come up on the stage and take their seats. Ladies and gentlemen, I'd like to request you all to please put your hands together for the chairman of the second technical session, Shri Ajit Pandit, Additional Member Works Railway Board, and the co-chairman of the second technical session, Shri Piyush Agarwal, Principal Executive Director, Bridges, Railway Board. And we welcome all the authors also.
The authors for today's second session are Anurag Kumar Sachan, Chief Administrative Officer, Udhampur Srinagar Baramulla Rail Link Project of Northern Railway, Shri Sunil Kumar Gupta, Deputy Chief Engineer, Track Procurement, North Central Railway, Shri MP Singh, Director, Bridge and Structures, Concrete Bridge 1, Research Design and Standards Organization, Shri P. Rajagopal Rao, Deputy Chief Engineer, Track 2, South Central Railway, Shri Lakshmi Narayan, Principal Chief Engineer, East Coast Railway, Shri Mohan Lal, Chief Bridge Engineer, Northeast Frontier Railway, Shri Sandeep Kumar Saha, Divisional Engineer, East, Ranchi, Shri Rajiv Kumar, Junior Engineer, Drawing, Ranchi, Shri Rajveer, Senior Divisional Engineer, Coordination, Katihar, Shri Rajiv Ranjan Kumar, Deputy Chief Engineer, Planning and Design, Allahabad, North Central Railway, Shri Rajesh Kumar, Deputy Chief Engineer, Track Supply, Allahabad, North Central Railway, and Shri Harsimran Singh, Senior Divisional Engineer, Coordination, Adra Division, Southeastern Railway. I now hand over the mic to the Chairman, Shri Ajit Pandit, Additional Member Works, Railway Board, to please take over.
There's just a slight pause. We're just pausing for a moment and it's not stopped, and we'll begin in a short while, waiting for the cordless mic to arrive though.
Good afternoon, ladies and gentlemen. We are starting the second technical session of the IPWE seminar, which is on leveraging developments in monitoring technology for optimizing bridge maintenance. We have a variety of papers with us today. We have got about 100 minutes and 10 papers, so 10 minutes each. We will give a bell at the 8th minute and 2 minutes more. The first paper is by Shri Anurag Kumar Sachan, CEO, the famous Udhampur Srinagar Baramulla Rail Link, and he is going to speak on the world's highest railway bridge across the river Chenab and the warning and structural health monitoring systems which they are going to put in place for this particular bridge. I would request Shri Anurag Sachan to kindly start the presentation.
Good afternoon, respected seniors and dear friends, ladies and gentlemen. It's a little difficult to make a presentation after a heavy lunch. But trust me, it's a very small, brief and crisp presentation on instrumentation on Chenab Bridge. As you can see on this slide, as a part of USBRL project, two very important bridges are being constructed. On the top left is Chenab Bridge, which is a steel arch bridge involving almost 30,000 metric ton of steel fabrication. And it is in advanced stage of completion. Almost 70% work has been done. The viaduct portion is already completed and the arch is being launched. So I'll cover the instrumentation of this Chenab Bridge. But another bridge I will definitely mention here on the bottom right side is Anji Bridge. This is going to be the first railway cable stayed bridge. And it was decided to make a cable stayed bridge because you can see that it is an unsymmetrical cable stayed bridge with a pylon height of 200 meters. And because there was no possibility of making any kind of deep foundation on the right side, that's why we decided to have a cable stayed bridge so that there is no deep foundation on the right hand side. Just I'll brief in few seconds about this project. As you can see from the top, the green line, that is Baramulla, Srinagar, Kazigund and Banial. This is a section 136 kilometers, which has already been commissioned. And this portion predominantly falls in the Srinagar Valley. It's a valley portion. It just crosses, you can see a hill, snow-laden hill. This is Pir Panjal range. Between Kazigund to Baramulla, there is a tunnel which is 10.25 kilometer long, which crosses and it comes towards the south. The bottom portion from Udhampur to Katra has also been commissioned, and the red line which is shown in between two sections is where the work is in progress between Katra and Banihal. This is 111 kilometer section where these two bridges are falling, Chenab Bridge and Anji Bridge. So this is a very treacherous section, almost inaccessible. We have constructed almost 200 kilometers of approach road to reach to the site. And these are the bridges which I'll cover it. As you can see, a very picturesque site of Chenab, but it was almost 20 kilometers away from any approachable road. So for approaching this site, initially 20-kilometer road was constructed and a road tunnel also was constructed. And as you know that Himalaya mountains are very young mountains, still there are movements. The temperature is sub-zero, and so we have to check the strength of steel up to a temperature of minus 20 degrees centigrade, because steel becomes brittle when the temperature goes down. Very difficult access, I have already told you. And there are disturbances in J&K area, because this area is hardly 50 kilometers from the Pakistan border. As you can see on the top photograph, this height of this bridge is 359 meters, which makes it world's tallest railway arch bridge, which is higher by 35 meters than the Eiffel Tower. The bottom photograph is of the arch foundation, which is 46 meter tall, and almost 20,000 cubic meter concreting has been done in this. This foundation has already been completed, and the work is further arch erection is in progress. In this photograph, you can see the top deck. This is a continuous steel girder. It is partly in transition curve, partly in circular curve, and you can see on the background there are workshops, steel fabrication workshops. Those complete deck has been fabricated in segments of 8 meters, and then it has been launched from one side. This is the crane which is known as cable crane. It is spanning across the river Chenab. Its height is 128 meters, and span is 915 meters. I think people say that the longest span in the world. and it can carry a load of 34 metric ton. So all the fabricated members of arch and the steel trestles are transported by this and lowered down for the erection. There is a view of one of the end of this bridge. You can see those steel piers are coming up. The highest pier will come over S40 foundation, which is 133 meter tall, and below this is that foundation of 46 meter height. So total height will be 136 plus 46 meters. There is another end where those steel piers are coming up. There is one photograph showing the erection of arch. There is a trial assembly. Before it is erected at the actual site, the whole trial assembly is fabricated on the ground, and the geometry has been checked, and after that it is deassembled and then transported to site. This is one other photograph showing the arch launching is in progress. Now here comes why we need the instrumentation, because so far in Indian Railways we are really not doing the instrumentation of the bridges. At the most, some of the drone survey has been started, and some underwater inspection is being done. But so far we have really not done kind of instrumentation which is required. And why we want to do this because it's a very, very complex structure. While designing this bridge, there are so many assumptions involved. So one of the ideas is to validate these assumptions. Then to study the behavior of this bridge when the trains are moving in the real situation. And environmental conditions are very, very adverse. There is a very high seismic load. This area falls in zone 4 of seismic category, but this bridge has been designed for zone 5. And there is a very high wind at this site because it's like a V-notch, the Chenab Valley. So this bridge has been designed for the wind speed also. So it is also required to, during operation, you have to see what is the wind speed. And there are extreme temperatures which varies from sub-zero to plus side. When this bridge was designed, it has been designed in stages. In construction stage number 1, when the arch was erected, because this arch is 467 meter, total span is 467 meter, and when you erect the arch, it is a cantilever. So when there is a cantilever, it has a different behavior. It will deflect, and you should know the deflection. So when the arch is closed, then it has a different behavior. And after the arch is closed, over that steel piers are coming up, that height of 133 meters. So again the behavior will change. So that's why at every stage there are assumptions. So it is very much required from the instrumentation that we do the validation of these assumptions. And finally, all these arches, concrete steel arch, it has been filled with the concrete. So again the behavior will change. And over that deck is continuous girder. I'll go a little faster because already there is a ring. So the 3 type of instrumentation is done on this bridge. One is to check the environmental conditions. Second is to monitor the structural health. And the third is stability of slopes, which is also very, very important as the bridge is important. This is a scheme for environmental conditions. You can see that those red dots is triaxial ground accelerometer, where we measure the earthquake frequencies. And then there is an anemometer on the top of the arch, which sees the velocity of the wind, and the temperature monitor, and the steel temperature also is being monitored. There is the anemometer, very simple. This bridge has been designed for wind speed of 266 kilometers per hour, and the limiting speed is 25 meters per second, that is 90 kilometers per hour. So this anemometer will give the signals. Wherever the speed will go beyond 25 meters per second, it will give an alarm, so that we can stop the trains. And this anemometer can work from minus 35 to plus 70 degrees centigrade temperature. This is triaxial accelerometer, which will be provided on both the foundations. This can record the earthquake vibrations at 0.1 hertz, and if the earthquake intensity goes beyond 2G, so it will give alarm, so we can stop the trains. Then contracted temperature sensors are there, that will be provided, one on the arch and one on the aqueduct. And these are the temperature monitors for the steel temperature, to record the steel temperature. The second category is warning the system for monitoring the structural health of the bridge. So there are tilt meters. 2 tilt meters have been provided on 2 tallest piers, one on the left side, one on the right side, the red dots. And then deck accelerometer is provided, so that after passage of each train, the acceleration on both the directions is measured to know the behavior of the bridge. And then the strain gauge is provided on the top deck. There is a tilt meter which will be provided there. This is a deck accelerometer. 2 numbers deck accelerometer will be provided on the top. And these are the strain gauges that will be provided on the deck to know the strain on the bridge. And the last one is slope monitoring. As I told you, that slope stability is very, very important, because a lot of slope establishment work has been done by 3-deck analysis, and some borehole extensometer has been will be used for this. These are borehole extensometer that will be provided in a 6-inch diameter hole, and at a distance of 8 meters, 16, 24, 32, and 40 meters. So these will be provided to know the movement in the rock mass. And these are the load cells which will be provided in, we have provided a lot of cable anchors for establishment of rock in the rock slopes, and Divideck bars it has been provided because it's a very fractured rock. So these load cells will also give us the information about the stress coming on the rock bolts and anchor bars. There's the architecture of warning system. There'll be a central control room, and there's a warning system of the bridge and warning system of the slope. The feed will come to the control room, and it will pass on the signal to train control and signaling system, so that train can be regulated. And the entire data will be monitored in a real-time basis in management information system. These are some of the equipments which are already there at site. It has been supplied by AIMEL Roorkee. They have the stall here. This is the list of all the equipments which will be finally installed on this bridge. And if you see the total cost, it is peanut. If you compare the cost of the instrumentation, it is hardly 1.25 crores. The cost of bridge is 1200 crores, so it is 0.001%. So I recommend that in all the mega bridges, like maybe Bogeybill in NFR and other bridges, such kind of instrumentation should be provided. Thank you very much. Thank you.
Thank you, Mr. Sachan, for a very illuminating presentation on the USBRL project, an overview and the monitoring systems which are going to be put in place on the Bogeybill Bridge, on the Chenab Bridge. In fact, we are also putting in similar systems on the Bogeybill Bridge also. So, and also we are looking forward to the completion of this project, because this is actually a very eagerly awaited project. Our second presentation is from Sunil Kumar Gupta on the GIS platform of Indian Railways, use of aerial mapping and videography by unmanned aerial system in routine bridge inspection and decision making. As we have been saying that we are in a dire need to reduce our manpower. So probably these are some of the answers which are coming out from this seminar as to how we could reduce our manpower in order to do the routine inspections. Thank you.
Good afternoon, senior officers, colleagues, ladies and gentlemen. In earlier presentation, the name drone or UAS has been used many a time. I will cover what a drone or UAS is, what are their advantages, what are the DGCA regulations, because it is not permitted to fly drone over Indian aerospace without permission. And we shall put few clips, advantages, etc. The topic is JS platform of Indian Railway, the use of aerial mapping and videography by unmanned aerial system in routine bridge inspection and decision making. So, US system is nothing but it is a drone. It has got a capability of mapping, monitoring, inspection, and planning for transportation corridor and projects. The geographical intelligence captured by drone technology is very helpful in damage assessment of life and property in area suffered by natural calamity and accidents, infrastructure monitoring, photogrammetric survey, and crowd management. Here we shall discuss for bridges inspection. There are around 1.44 lakhs bridges in Indian Railways, which include 680 important bridges and around 12,000 major bridges, which needs periodic monitoring, inspection, maintenance, and bridge strengthening to ensure the safe and efficient, speedy passage of traffic over them. So, what are the conventional system of bridge inspection? It is being carried out with the help of mobile inspection unit, on-foot inspection, inspection with the help of rope access, jhulas, ladder, and with the help of boat with binoculars, etc. There are certain limitations with the use of these conventional system, which are difficulty in inspection of inaccessible portion component of bridge, and difficulty to carry out inspection in running traffic condition, requirement of trained manpower, which is a very scarce commodity now, availability of a scarce traffic block, and at the last, safety of inspection staff. Whenever they inspect on the unsupported part of the bridge, normally they avoid using any type of safety ropes, etc. So to overcome these limitations, shortcomings, we can use unmanned aerial system. The unmanned aerial system is nothing but it is a part of unmanned aerial vehicle, a remote pilot station, a command and control line, and an operating personnel. So to carry out this inspection, first the planning of and site visit is being carried out. Then the data is being captured with UAV. Field measurement is correlated. Then data is being analyzed in the field and finding and highlighting the area of concern to the person concerned. These are various types of unmanned aerial vehicle available which can be used. The top two photographs is quadcopter. These are multicopters, means quadcopter or hexacopter, which can be take off and land vertically, and the bottom two are fixed wing type. The first one is pusher type with belly landing, and the second is pusher type with landing gear. Advantage of using UAV. It provides a tool to view and assess the bridge element condition and take decision accordingly. It provides easy access to the hardest to reach places of a bridge, which is not visible neither from the bottom nor from the top. Risk associated with the working at height and in running condition is minimized. No traffic block or disruption to traffic is there. Defect can be identified and referred to higher up for decision making. It provides an aerial view of map of the bridge and surrounding. The geotag orthophoto is able to provide ground dimension. The trial was carried out for bridge number 30, which is a rail cum road bridge across river Yamuna in Naini Allahabad section of NCR. It has got 14 span plus 2 approach span. Each span length is 61 meter. So here are some visuals we have taken. start getting.